Very good afternoon, students.
Good afternoon, sir.
Good afternoon, sir.
Good
Good
afternoon.
afternoon. Good afternoon. So very soon we are going to start the lecture. I will wait for a few more minutes, otherwise I will start the session. As per our yesterday's discussion, we were being told to write down the parameters, that is HI, HO, HF and HR for all the three configurations. I hope you remember the task and you might have completed that task. Yes or no?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay, Kush. So students, based on HIE, HRE, HFE and HOE, this is the H parameter AC equivalent model for CE amplifier. All of you are requested to kindly draw the model. Once you draw the model, please let me know.
Done, sir.
Okay.
Done, sir.
Okay.
Done,
Done,
sir.
sir.
Okay. So as you can see in this AC equivalent model, the very first is HIE. HIE is basically nothing but,
Input impedance.
yes, as it is input impedance, so definitely it would be in the input side of the AC equivalent model, and HIE is drawn as it is. The HRE is open circuit reverse transfer voltage. Since it is reverse transfer voltage, so I mean to say that it is VI upon VO. So VI upon VO, if we talk about, then in this particular case, it will become
શું કરો છો બર્થડે की પાર્टी વાર્ટી ક્યારે આપવા મને હું એકદમ મારી રીતે અલગ વાત કરી તો આ એકદમ તમને
26 number, you are requested to keep yourself muted if you are in home so that the others do not get disturbed. I continue with the topic of HRE. HRE is nothing but VBE upon VCE, as you have already written. So now if I multiply this thing, this would become our input voltage. Yes or no?
Yes, sir.
Similarly, on the other hand side, we are having HFE. HFE is nothing but IC upon IB. So our collector current is going to HOE, which is IC upon VCE, which is IC upon VCE. That is totally nothing but our output current and output voltages. Now the thing is that in the given circuit, HRE and HOE are very small. I repeat, HRE and HOE are very small. So the circuit would be modified. The modified circuit is something like this. Please draw the modified circuit because HRE and HOE are very small. Once you draw the circuit, please let me know. These all things we have already done in 3110016 subject. So it's just a repetitive task.
Done, sir.
Done, sir.
Okay. Now, this was H parameter AC equivalent model. Next, we are moving towards hybrid pi model of CE configuration. Next, we are moving towards hybrid pi model of CE configuration. This is hybrid pi model for CE configuration. Please note down the parameters as well as the circuit. In case anything is not visible, please ask me. In case anything is not visible, then please ask me. As you can see in the circuit, there are few important parameters being written. The first parameter is G subscript M. G subscript M. Basically, it is known as transconductance. The formula is IC upon VBE. As you already know, IC is the output current, VBE is the input voltage, and the constant terminology is VCE. The second parameter is R subscript pi, which is commonly known as beta upon GM. Beta upon GM. The third parameter is output resistance, that is R0, which is equal to output voltage upon output current when input is constant. Here there is one new terminology which is known as VA. VA is nothing but early voltage. What is early voltage? That you will just know after the things that you have written. Please let me know once you have written the whole stuff.
Done, sir.
Done, sir.
Okay. Okay. 11 number, 13 number, is it done?
Yes.
Okay. Please note down. Variation. Next point. Variation in effective width of base in transistor due to variation in applied VBC. VBC. Next point. Greater reverse bias across CB junction increases CB depletion width and hence decreases the width of charge carrier portions of base. This effect is known as early effect. Early effect. Basically, we are talking about this. As you can see that the reverse bias across the CB junction is increasing. As a result, the depletion width over here, this depletion width is increasing quite a lot. As a result of which, there is a decrease in width of charge carrier portion. That is, this overall width is decreasing. With this decreasing width, everything is going to get affected, and hence this is the early effect on transistor, and hence this is known as the early effect on transistor. I hope you are able to understand this diagram. I would like to repeat the diagram again. E, B and C, all the three terminals are being connected respectively. The CB junction is reverse biased at a higher value or at a greater range. As a result, the depletion width of CB is quite large. Hence, there is a decrement in the width of the charge carrier portion of base. You already are aware of two terms, that what happens when depletion region is wide and what happens when depletion region is narrow. Please respond yes or no. Are you there, students?
Yes, sir.
I hope you have written what do you mean by early effect on transistor.
Yes, sir.
I would like to ask enrollment number 46, are you there?
Yes, sir.
Because when the depletion region is wide, what happens? It is in which particular bias region?
So, reverse bias.
And when the depletion region is narrow, that means it is in which particular bias region?
So, forward bias.
So as you can see in the circuit, your base is always forward biased and vice versa is the case of emitter and collector. Yes or no?
So, yes, sir.
Okay, thank you 46. So students, I hope you have noted the diagram. If you all have noted the diagram, can I proceed further?
Yes, sir.
Just wait for 1 minute. Before we proceed for the first unit, before we proceed for the first unit, first and foremost, you must understand what happens to transistor at low frequencies. Thereafter, we will see how the transistor reacts or operates at higher frequencies. So all of you are kindly requested to note down few points. I hope my voice is audible and the screen is clear to all of you.
Yes, sir.
Yes, sir.
The very first and the foremost point is, at lower frequency, at lower frequency, transistor responds immediately to the changes in input voltage and input current.
Hello, sir.
Yes,
Can you repeat from transistor?
yes. At low frequencies, transistor responds immediately or instantly to the changes of input voltage or input current. As a result of which shunt capacitance, I repeat, shunt capacitance is being neglected. I hope you have written the first point.
Yes, sir.
Yes, sir.
Please note down the second point. Because of transistor analysis, even H parameter is suitable only at lower frequencies. I repeat, because transistor analysis is H parameter analysis is suitable for transistor analysis only at low frequencies. At higher frequencies, these models do not work properly because of its parameter variation. I repeat, for transistor analysis, even H parameter is suitable only at low frequencies. At higher frequencies, these models do not work properly because of parametric variations. Because of parametric variations. Next point, H parameters remain constant at lower frequency, but at higher frequencies, these parameters vary a lot. vary a lot. Therefore, it is necessary to analyze transistors at each stage and at each frequency level where the chances are less. Next point. Yesha, are you having any problem?
Sir, can you please repeat after therefore it is necessary
To analyze transistor at each stage and at each frequency levels.
Thank you, sir.
Next point. At higher frequencies, H parameters becomes complex. So, hybrid pi model is used for higher frequency analysis. My dear students, in basic electronics, we have studied how BJT operates at small signals or at low frequency levels. There were three basic configurations like CE, CB, and CC configurations. Transistors were operating very well at lower frequency levels. But as we increase the frequency parameters, what we observe is various transistor parameters act accordingly and change the values which are to be remained constant. So, transistor parametric evaluation is not proper at higher frequencies. For the very same reason, instead of moving with H parameters, which is commonly known as hybrid parameters, we move on for hybrid pi model analysis of transistor. Transistor H parameter models in high frequency not only change or vary its value, but practically it is impossible to measure them. As a result of which, at higher frequencies, values of these parameters become complex. So, to analyze transistor at those higher values, we must use some different model or parametric equations. The preferred model for use for a BJT, NPN or PNP transistor at high frequencies is commonly known as hybrid pi model, which reflects that the values of those hybrid pi models or the parametric values would remain constant with higher frequencies. I hope it is clear to all of you. Any point or any topic is remaining, please do let me know. My dear students, please do let me know. Hello students, is anything remaining?
No, sir.
Enrollment number 36.
Yes, sir.
Is anything remaining or have you written all the points?
सर वो हाइब्रिड वाला तो आपने लिखवाया ना लास्ट में,
हाँ,
वो वो बाकी है, वो हायर फ्रीक्वेंसी एनालिसिस तक लिख लिया.
क्या पॉइंट लिखा है प्लीज बताओगे?
At higher frequency, H parameter becomes complex, so hybrid pi model is used for higher frequency analysis.
बस इतना ही बोला था.
उससे आगे नहीं लिखा.
हाँ, उसके आगे कुछ बोला भी नहीं, उसके आगे से समझाया था मैंने.
हाँ, ओके.
49. Have you written all the things? Can I proceed?
Yes, sir.
Students, I hope my screen is visible to you.
Yes, sir.
Yes, sir.
Yes, sir.
The screen represents hybrid pi model of CE transistor. Kindly mark it as figure number 1. It is also known as Gia-Coleto model. It is also known as Gia-Coleto model. Please note down each and every abbreviation so written accordingly. Just now I have explained why transistor H parameter model cannot be used for higher frequency analysis, and hence we are using hybrid pi model for the same very reason. So whenever it is required or being asked the reasons for not using H parameters as compared to hybrid pi models, you must be able to justify the same. Are you having any doubts in it? There is one small information to be passed upon. On Monday 3:30 you were having the lecture of principal sir. That would be continued from the coming week, that is from 21st onwards. Due to some reasons, the lecture was not being conducted in the previous week. In the coming week or in the coming weeks, this thing happens. You can directly contact HOD sir for the same. Few students tried to contact me at the same moment or Samir sir for this particular lecture of Monday 3:30, but we both are having lectures at that time. So students are requested not to call us, directly call head of the department for the same. Because of some reasons, it may happen that sir might be in a meeting. He would try to inform you in prior, but in case this thing does not happen, please contact HOD sir. I request not to contact me or to Samir sir in between because our lectures are going on at that time. I hope you all understand.
Yes, sir.
Have you drawn the Gilakota model? Can I proceed further?
Yes, sir.
Yes, sir.
Instead of EBC, you can observe I have drawn one extra B over here with a dash on its top, which is known as B dash. Are you able to see that?
Yes, sir.
Yes, sir.
This B dash is not physically accessible. It is only virtually present. This B dash is not physically accessible. It is only virtually present for the sake of our convenience. Please note down hybrid pi model CE transistor. Hybrid pi model CE transistor. For this particular topic, there are few definitions that you must understand to define few terminologies that have been written in the diagram. I hope the diagram is very well clear and each abbreviations and notations you have already noted. Please do let me know if anyone has not noted. 22, 23, 21 Tanmay.
Noted,
Yes, sir.
Yes, sir, done.
Tanmay,
Yes, sir.
your email ID is tanmay101101 @ gmail.com.
No, sir. It's Tanmay 1010.
Okay, tanmay1010 @ gmail.com.
Hmm.
Okay. You might have
Sir,
observed. Yes, please.
so I will message you my email.
Yes. You might have observed that today the whole class has been given access to a particular folder. This particular folder is lab-wise task for this particular subject of 3141002, which is analog circuit design. Each and every individual of the class must submit weekly experiments in scanned copy form or simulations in the respective formats in that particular folder only on weekly basis. The access is being given to all the students individually. So all of you are requested to submit the experiments scanned copy individually in your respective folders. Based on that, everything would be counted. I hope this message is clear to all. Have you all received the link or not individually?
No,
Yes.
sir, I
I have.
didn't.
Yes, sir. No, sir. No, sir.
36 को नहीं मिला और किसी को नहीं मिला? Except 36, anyone else who has not got that link?
Sir, 46.
So 19.
19 आपके हॉटमेल वाला और जीमेल वाले में दोनों में प्रॉब्लम्स आ रही हैं, तो आपका जो एनरोलमेंट नंबर है
हाँ
19011019@gset.ac.in, उस पे एक मेल सेंड किया है।
सर मैं देख लेता हूँ।
और 46
हाँ
46
Yes.
यस
सर आपके भी उसी तरह से हमने सेंड किया है, आप एक बार चेक कर
कौन?
लीजिए। एक मिनट
Sir.
जस्ट वेट, एक मिनट जस्ट वेट।
Yes. Yes. I got it.
Okay,
Hello.
I think you got it at moaz78662@gmail.com.
Yes, sir. Yes, sir.
Okay. Enrollment number 36, we are not having your email ID, but the email ID that we have received is Dheeraj Prajapati 442002@gmail.com.
No sir, I have given the our counselor Mayank sir DGP वाला दिया था।
What I request is, Dheeraj, kindly give this particular email ID, whatever you are accessing, to your respective lab teacher, that is Professor Karthesh Mankori. So he will give you the access of that particular folder.
Hello, sir.
Hello 36, am I
Yes.
audible?
Hello.
36,
हाँ
yes
sir.
sir.
Yes, sir. You are right.
So please give this your respective email ID to Parthish sir 36. Okay.
Okay sir. Okay.
हाँ रितु बोलो बेटा, क्या हुआ?
सर मेरा भी नहीं आया।
बेटा आपको रितु पटेल 2129@gmail.com पे किया है।
हाँ एमा सर नहीं आयु।
जस्ट वेट अ मिनट, હું ચેક કરી લઉં છું। વીકલી બધાને આ ફોલ્ડરના અંદર જ એક્સપેરિમેન્ટ્સ મૂકી દેવાના આવશે। Ritu, you are in B11 batch, right?
Yes, sir.
बेटा ईमेल आईडी बोलो ना।
Ritu Patel 2129
Okay,
@gmail.com.
just wait a minute. Please note down few things. Point number 1, internal node B dash is not physically accessible. Internal node B dash is not physically accessible due to early effect voltage,
Sir, can you please repeat?
yes, internal node B dash is not physically accessible due to early effect voltage varying across CE junction, varying across CE junction, results in base width modulation, results in base width modulation. I repeat again, internal node B dash is not physically accessible due to early effect voltage varying across CE junction results in base width modulation. Can I proceed?
Yes, sir.
Yes, sir.
Please note down the second point. The change in effective base width, effective base width causes IE, I subscript E to change. This feedback effect, this feedback effect between output and input this feedback effect between output and input is taken into account by connecting R B dash C R B dash C between B dash and C, between B dash and C. The second point that you have noted is for second diagram. The second point that you have noted is for second diagram, which is written in numeric 2. I hope numeric 2 figure is being clearly seen to all of you. Let me know in case the figure is not visible. Is RB dash C visible to all of you?
Yes, sir.
Yes, sir.
RB dash C is basically due to the effective change in the base width because of IE. So it is known as the feedback effect between output and input. Input was B dash, output was C. So between B dash and C, known as RB dash C. Is it sound and clear to all of you?
Yes, sir.
I request all the students to kindly join the lecture in time. Today, all of you have joined the lecture 8 to 10 minutes late.
Cash and cash.
Can I proceed for the next point?
Yes, sir.
Yes, sir.
Please draw both the figures, figure number 2 and figure number 3. Once you draw it out, then let me know.
Done, sir.
Okay,
Yes, sir.
okay.
Done, sir.
Okay. I would like to ask, what do you mean by diffusion capacitance? Diffusion capacitance. What it is? Yes, enrollment number 45.
Yes, sir.
Financial cost.
What is diffusion capacitance? Yesha?
Yes, sir. Yes, sir. Sir, the capacitance which is used for to transport charges from one terminal to another.
Enrollment number 50, would you like to express something more?
No, sir.
Kush, would you like to add something more to it? What is diffusion capacitance? Or what it is,
No,
how it is
sir.
created, what happens? Where have you heard this topic? Something like that.
Idea nahi.
Okay. Please note it down, all of you. When PN junction diode is forward biased, a capacitive effect, I repeat, when PN junction diode is forward biased, a capacitive effect is being established, which is known as diffusion capacitance. Which is known as diffusion capacitance. This effect of forward bias BE junction, this effect of forward bias BE junction is referred as CB dash E or CE? CB dash E or CE? So here
Sir,
in
can
this
you repeat?
diagram, yes please.
Sir, can you repeat? वो फर्स्ट वाला नहीं, दूसरा वाला.
मैं पूरा पॉइंट रिपीट करता हूं, आप देख लीजिए. When PN junction diode is forward biased, a capacitive effect is being established, which is known as diffusion capacitance. The capacitive effect of forward bias BE junction is known as CB-E और CE. यहाँ पर जो फिगर नंबर 3 में आपको CBE दिख रहा है, टेक्निकली वो CB-E होगा, क्योंकि ये डैश्ड लाइन है. डैश्ड लाइन का मतलब ये होता है एक इनहेरेंट कैपेसिटेंस है, मतलब it is virtually present but physically its value is very less. Physically B और E के बीच में कुछ हो सकता है, पर ये जो CB-E है ये एक वर्चुअल कंपोनेंट है जो एग्जिस्ट तो कर रहा है पर प्रैक्टिकली वो नहीं है. So this is CB-E or commonly known as CE, which is known as diffusion capacitance. I hope you understand this thing.
Yes, sir.
Yes, sir.
Yes, sir.
So students, that's all for today's class. We will continue the next topic in our next session, that is tomorrow at 11:30. In case of any doubts or queries, please feel free to ask. Otherwise, we may leave the session. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Hello, sir.
Hello.
Sir, 19.
હા મોશી, મેં તારો મેલ જોયો, અમે એમાં કનેક્ટ કરવાનો ટ્રાય કરીએ છીએ, પણ બેટા પ્રોબ્લેમ ખબર નહીં શું થાય છે. અહીંયાથી એવું લખેલું આવે છે કે this email ID is not working properly. There is a internal error. એટલે છે ને કંઈક બીજી પ્રોબ્લેમ થઈ છે, ખબર નહીં. તું એકવાર સાહેબ જોડે વાત કરી લેજે ને 1B11 માં પાર્થેશ સર જોડે.
સર કઈ મારી બગ નથી એટલે એમાં ખાલી
જે તે મેલ કરીને મેસેજ નથી કર્યો હમણાં તે.
હતા કરી મેં મેસેજ તમારે સર.
હા હા, જો હું તને તું અહીંયા જ રોકાય ને, હું તને શેર કરું એક વસ્તુ, બાકી ઉધર જવા દે, પછી જોડે શેર કરું. ઉભો રહે.
હા.
મોશી સ્ક્રીન દેખાય છે ને બેટા?
ના સર.
જસ્ટ વેટ.
યસ સર, ઇટ ઇઝ વિઝિબલ.
હા જસ્ટ વેટ, હું આ શેર જ કરું છું.
સર અને વચ્ચે લેક્ચરમાં મારી ઇન્ટરનેટ કનેક્ટિવિટી આવી ને તો ડિસ્કનેક્ટ થઈ ગયેલો હું.
હા વાંધો નહીં.
સર એ નથી ચાલતું મારું.
નથી ચાલતું ને, હું આજ તો કહું છું. અચ્છા મોશિન વાળો ચાલે છે ને?
3 ચાલે. હા એ ચાલે છે.
હા એક જ મિનિટ જોઈ લઈએ, ચાલતું હોય તો સરસ. તને વ્રજે કોન્ટેક્ટ કરેલો?
ના સર મને કોઈનો ફોન નથી આવ્યો હજુ.
વ્રજ વાણિયાવાલા, પેલો D2D સ્ટુડન્ટ.
હા હા સર એને કર્યો હતો.
એને મટીરિયલ કઈક જોઈતું હશે.
હા આપ્યું.
ઓકે ઓકે. ને પણ આપો, અમે ગરીબ લોકો છીએ. હેલો.
હા સર આવી ગયો ઇન્વિટેશન.
હા પણ અમને પણ ક્યારેક ક્યારેક મટીરિયલ શેર કરો બકા.
સર મટીરિયલ નથી મારા એટલે આ પેલી બુક સર તમે બતાવી લઈ હવે ચાલશે?
કઈ બુક છે? હા ચાલશે ને, બોય સ્ટાઇલ છે ને.
11th એડિશન છે ભાઈ.
હા તો ભાઈ 11th એડિશન તો અપલોડ કરી.
ના સર તમારે ત્યાં 10th મેં જોઈ લઈએ હવે.
ઓકે કઈ વાંધો નહીં, ચલો બાકી બધું બરાબર ને?
હા સર
ઓકે બાય.
ચાલે છે તો કમ્પ્લીટ ચાલે.
સરસ સરસ, ચલો એન્જોય કરો.
થેન્ક યુ સર.
ઓકે બાય.